Good day, everyone. It is my pleasure to host Frost Sullivan's Growth Webinar on Industrial AI's Missing Middle. For today's conversation, I have two esteemed panelists, Boris Sharinga from Siemens and Miroslav Kritz from Momenta Ventures. I'll briefly introduce the two of them and we will jump into the conversation. So Boris Sharinga, he is a senior innovation manager at Siemens. He has been serving Siemens Digital Industries, the Industry 4.0, and the PLM software division of Siemens in numerous initiatives centered on industrial grade AI, as he likes to call it. He has an experience that spans more than 3 decades, and he has a unique, broad background that bridges the gap between complex IT infrastructure and strategic business innovation. But what I've come to learn from Boris is that he is now wearing a new hat as an author, and he has already penned a book on industrial AI. It's yet to be released, but you can start ordering it, I think, from April. So it's called Industrial AI from Pilot to Profit. It's very closely aligned with the conversation that we'd like to have today. We wish Boris all the very best on his new endeavor as an author. Next in line is Miroslav Kritz. Miroslav is a seasoned leader in finance, go-to-market, and product strategy. He has a very esoteric or eclectic experience. He's as an operator, entrepreneur, and an artificial IoT-enabled SaaS specialist. I haven't come across a mix like this, to be very honest. So his most recent roles include head of finance and strategy at Axino AI and head of strategy at SmartSense by Digi. So Miroslav is a passionate advocate of Industry 5.0, which is, for those of you who are not in Europe, is the next version of Industry 4.0 that bridges ESG along with the Industry 4.0 ideals that we set in place 10 years ago. It's an European Commission initiative. Miroslav also believes in harnessing the power of overlapping technological innovation platforms to drive sustainability. He's based in Prague, the Czech Republic, and he's committed to fostering connections between the Central Eastern European region and the United States through the startup ecosystem. I'm certain that Miroslav will have some rich perspectives coming from the venture capital world of industrial AI. Miroslav and Boris, thank you very much for taking the time to be in this discussion with me. So I want to keep this as organic as possible, and I'm going to start off with a very broad question, and I will leave the two of you to decide who wants to go first. So we've been talking about industrial AI for more than 2-3 years now. Much water has passed, I would say, since the topic got introduced. Again, it gained a lot of steam after the ChatGPT announcement came in the consumer world. So we've started talking about industrial AI then. So this goes back to 2022. But where we are today, we see that the use cases for industrial AI have been proven more or less at small scale, but there is still a big gap between pilot and enterprise deployment. It's quite a wide gap. So in your own assessment, what do you think that we are closer to closing that gap? Or do you think the industry has been saying we're almost there for too long?
Miro, please.
Oh, thank you. It's interesting where we see the most, it's definitely gotten better, right? Where we see the most positive work is at the process level where there's defined variables and you can have a closed loop in some way where AI can even start decisioning. I think where we struggle still is factory-wide deployments, and maybe quite a bit of that is due because we still think of how to do this in an OT kind of way, where a factory has a budget and things are local and there's no necessarily overarching strategy that's done in more of an IT strategic way, right? So that's where I think we're still missing that piece. Is sometimes you still talk to procurement leaders who are doing global MFAs, and they're still thinking about how do I get the best discount on this product instead of how do I transition my company to be AI enabled or AI native.
Interesting.
I can relate to that specifically also to the fact that a factory as an own entrepreneur, they do their own commercial decisions, and then immediately you fall into the trap of a lack of standardization. And then a lack of standardization really makes it difficult to roll out AI on scale. I'd like to add another perspective. So, have we been waiting for too long? I think so, yes. I'd like to separate a little bit the product design and PLM side from the shop floor side. And why am I saying this? Because the new excitement that we see with the arrival of the GPTs of this world really is driving momentum into the adoption of AI. A lot of initiatives, a lot of funding, a lot of venture capital. And we still see those initiatives hitting a wall when you kind of knock on the door of OT environments. But you see these initiatives being pretty successful when you enter the pure digital environment of PLM and product design. So there's a lot of potential on the left side of the equation prior to production, still in industry. And product design, model-based system engineering, requirements analysis, the generation of CAD models, AI accelerated simulation. This is really gaining a strong momentum. And then as soon as you hit the bloody investment cycles, of machines and production lines, they have been built for 7 years. The machine doesn't produce the data output that is required for AI. Can we replace the machine? Can we upgrade the machine? No, we can't. We have to wait until the investment cycle is over before we can reinvest, right? This again slows adoption down, and I'm not seeing a strong momentum in these areas.
Very interesting. So in what you're essentially saying, we have to classify industrial AI into two clusters, the upstream and the downstream. Upstream is where, product design and engineering comes in, the PLM angle. And then you have the downstream, the OT side, where actual production happens. And I can perfectly understand when you say that the amount of effort required to permeate industrial AI in the downstream, in the actual production, is huge. So the question then that I would like to ask here is, do you think industrial AI is more a product or a PLM initiative and less of a OT initiative? And let me be very, very candid. I really want to come to the crux of this issue because we, in the industry, I think I want to shift the Overton window, as they call it. There is a lot of marketing that has been going on in the industry. As an analyst for 15 years, I use that here just for the sake of bringing some credibility. I've seen a lot of these initiatives come and go. And I really don't want industrial AI to go through that, marketing overdrive. So in that sense, the Overton window has to be, is this innovation going to benefit the OT side of the industry? We've seen Industry 4.2 in a sense not achieving the results, and I'm being euphemistic there. So I want to see if industrial AI for OT, is it something feasible or not?
My perspective again, the more digital we are, the faster is AI adoption. And this is why the hype that we see that swaps over from consumer businesses and from social media, because adoption is super high, right? If you are super digital in the business of a lawyer, right, shaping contracts, then everyone is excited about generative AI to produce, generate, and adjust legal texts and contracts, right? So this is making a huge impact. Why? Because it's digital. The OT side of life is not digital. It's partly digital. It has digital twins, but we are in the beginning of all of that, right? It's physical, and it follows investment cycles of machineries. So eventually we will be getting there, but it's a lot slower than everyone anticipated, particularly everyone who gets kind of influenced from the marketing hype that comes from social media and the such. And that's the challenge, that we need to reset the expectations for the speed of adoption of AI in the physical space of industry. And then everyone immediately thinks of physics, right? And the laws of physics. that's one part of it. And we see with robotics that this is not easy. I don't like the humanoids, by the way. However, it's not just the physical aspect, the physics aspect of it. It's also the investment cycles in machinery and the, when you build a plant, you build it for 10 years plus, you build it for 15 years. If you build a production line, you build it for 7+ years. And that is truly limiting the adoption speed of AI across the board.
Yeah, I mean, we see this, AI and startups in general will attach where they can, right? And if it's treated as a product or vendor purchase in a siloed way, it's going to create limited ROI, really. And I think now, especially, even the legacy automation companies are starting to think about not being so much of a walled garden, starting to abstract things like PLC, becoming software defined, and then enabling or becoming that foundational layer on which now AI and startups can attach in a more unified way. So this is what we see, and we think it's really encouraging. And we tend to look at the OT or shop floor side much more because we feel like while there was a lot of problems there, and you almost always needed an integrator to even get a custom solution working, we believe that catalyst is going to start where all the legacy automation companies will now allow people to build on top of it, kind of like the Apple App Store moment for industrial.
So let me add a bit of color to this, and I'm just basing this on my own research. Now, when you look at industrial AI as an innovation, it's primarily now being driven in the industry by industrial automation companies and industry software companies, including the startups Miroslav you mentioned. But I think the real challenge, especially from an OT adoption standpoint, is the fact that, as Boris mentioned, we are talking about a largely physical infrastructure that needs to adopt a highly, I would say, hyper version of digital, which is industrial AI. Now, there needs to be a gap that needs to be filled. So there are two issues that I see, two risks. So there's a co-innovation risk. So for industrial AI to be adopted on the OT side, we need, adequate data infrastructure innovations to be commercialized and adopted. You need, advanced connectivity standards to be implemented. So, and then you need as well cybersecurity initiatives to be put in place. And then you have another set of risks, which are adoption chain risks, which is an industrial software company or an industrial automation company coming up with their industrial AI proposition can only succeed if the subsequent, I would say, partners in the value chain, which is especially in the OT adoption standpoint, we are talking about system integrators, for instance. We also need to look at MES and SCADA and DCS system providers in the case of process, and we also need EPC contractors to come in, to kind of buy into this idea before it reaches the end customer. And my own research has led me to this conclusion that the reason why we are seeing a delayed or a very slow adoption of industrial AI to the point that many are giving up on OT adoption is not because the innovation of industrial AI in itself is not having value. It is just that we need these two risks positions to be addressed adequately. Now, I can say the co-innovation risks are being addressed because now we have a lot of companies coming up with all the innovations required for a solid industrial AI value proposition. But the real challenge is in the adoption chain risk. And I'm not seeing any major initiative being done or being taken up by the proponents of industrial AI to help the adoption chain adopt. I'll give you an example. I know it's long, but just to set the context. If you look at digital cameras, digital screening of movies, and this goes way back from the analog reels to digital cinema. What eventually ended up happening was it took a long time before it became a reality in that space. And the way it got addressed was finally the companies producing these digital cameras, digital, I would say, cinema, they had to incentivize the theater owners by giving them the ability to buy equipment that can project digital cinema. Take the case of Amazon, the Amazon Kindle, for example. Ebooks and ebook readers have been there for a long time. We had companies like Sony introducing them, I mean, very early, but it never took off. It only took off on Amazon, which in itself was selling books, was also able to offer publishers who were part of the adoption chain incentives, and it took a bit of, I would say, a cut in its own profits before it ensured that everybody started seeing value in the ebook industry. And now Kindle is what we all go to. Now, I think something similar needs to be done for industrial AI to become a reality. I may be going very abstract in my own theory, but I really want you to weigh on these two things. And at the end of this conversation, my essential desire is to identify where exactly we are failing right now, that's stopping the value chain from realizing industrial AI's value. Sorry for the, I know that was a bit labored, but I hope I kind of got the message across.
You
Yeah,
maybe your thought? Mhm.
I think, this is the classic dilemma where you have large market cap or market share of something, and you know that you have to change it, but changing it means cannibalizing your old processes, right? So right now, operators are working incrementally, helping a little bit on the edges, but they haven't been given the platform to really change and modernize. Whether it's the legacy automation companies that decide to do this, and it'll be painful at first, but then very fruitful, or someone with a lot of money decides, hey, I'm going to now create the next thing without all the legacy debt. That's the question. And to Boris's point, industry was so waterfall in development for so long, and we're finally getting to the point where we might actually be able to think about it in a more agile, incremental development way as things get abstracted from the factory. Obviously, actuators and motors stay, but quite a bit of things can get abstracted over time.
Couple of thoughts also on this. First of all, what Amazon did with Kindle is a multi-sided marketplace because that's their speciality. And then the second topic in the space of ebooks is certainly that all of the content is digital, which helps tremendously, right?
Yeah.
So that's why I find it difficult to compare to the industry that is, from a business model perspective, far away from a multi-sided marketplace, multi-sided platform economy approach. And every IoT platform that has, we try to establish, Siemens try to establish, AWS and others, failed with regards to that promise of becoming a multi-sided market in a sense. So this is one aspect. The other aspect is we are not starting greenfield. Production is running, and production is running stable. So we must acknowledge the reality of our customers, the reality of our, of a production manager who says, I'm running this production for 10 years and I'm optimizing this production 10% per year. And I have been doing so for the last decade. So now you guys are coming and you are injecting fragility with your bloody AI solutions into my stable production with the promise that it's going to be a couple of percentage points better than before, right? So we have running systems, we have smoothly running systems, and we have running systems that are running for a reason. Everyone is focusing on stability. Never touch a running system, make the processes stable, don't add anything probabilistic and so on. And now the AI guys are coming. So it's not just changing the interaction and the way the market works in terms of multi-sided marketplace and platform economy and all of that stuff. It's also physical, and it has been there for a good reason, and it has been stable for a good reason, and now we are injecting fragility. So there's friction. And this friction, I tell you when this friction will go away. We had something similar in IT before we had virtualization. So I remember, as an IT service provider, that we could charge prices like hell when we sold a highly redundant Oracle database mirrored being the base of a mission-critical HR and payroll system. We could charge like hell. Today, you cannot charge for redundancy and 99.999% uptime anymore, because the fully meshed cloud infrastructures of the hyperscalers are providing that type of redundancy kind of anyways. And we can all benefit from it with a very cheap price point, because stuff is virtual, databases are virtual, servers are virtual, and all of that stuff. And we, all of us in industry, are just at the very, very beginning of virtualizing PLCs, virtualizing the OT layers, introducing containerization into the shop floor. In 20 years from now, that stuff will be there.
Yeah.
In 20 years from now, we have another 2 or 3 investment cycles of production lines. And at that point in time, there will be open doors for any AI solution and any startup that wants to roll out an AI solution fast to get 2 decades from now.
2 decades.
Yeah, and more than just 2 decades, it also probably requires some kind of existential threat where there is no alternative but to do a transformative change, right? Otherwise, why not just go with what's working? And if that's a 30-year-old plan, that's fine. If the owner feels like it's working, then they're probably gonna stick with it. But Momenta and the startup world thinks 5-10 years ahead. And then we feel like it's coming faster than people will realize, and it'll take quite a bit of planning to get there and not die.
So maybe I can ask a question there, Miroslav. So what do you think would be the motivation for that operator that Morris mentioned, who basically sees things working fine, and he naturally is reticent to getting some new fragility in the system? What will really drive him to do that in 5 to 10 years?
I think there's very little, right? It's so funny because especially in Europe, the companies we see adopting AI the best and actually giving startups a chance are family-run manufacturing companies, because they're the operators, but they're also the owners, and they can decide, hey, this thing has been in my family for 200 years and I don't want it to die, and I am really scared it's going to die in 10 years, and let me try to fix that right now. But if you don't have that connection or ownership to the company, and you're just a operator and it's just your job, there's so much employment risk, there's so much other risk associated with trying to create a dramatic change. It really, unfortunately, has to come from the top down in a lot of these circumstances. I think there's potentially going to be a lot of green fields. There's so much money coming into physical AI. You're going to see entire new sections of green fields coming in, and all of a sudden, all these brownfields have competition that they've never experienced before. And that might be one of the catalysts.
Makes sense. Boris, any thoughts on that?
Well, coming from the IT industry, I saw terrible things happening. If you were a traditional IT service provider, having your own data centers, building up your own server racks and so on, you would, at a certain point in time, simply swiped away by the hyperscalers and by hyperscaler technology, because the idea that you can do stuff software defined is very, very powerful. Infrastructure as a code now exists, I would say, since 2012 or something like that. And we have so many applications, think of all the SaaS concepts. Think of you guys and me guys doing software development by prompting. All of that stuff wouldn't be possible without infrastructure as a code, without kind of virtual server deployment in the background, and containerization and all of that stuff. Now just project this onto the world of production, where lot size 1 is a thing, total flexibility, changing a production line by software. Imagine what that could mean, almost on a mankind level, right? And I think that this is the reason why we see a couple of huge venture capital bets on physical AI and on the future of manufacturing, because they are saying in 15 to 20 years, stuff will look completely different than it does today. Now it's a bet, right? It's a bet. But I think, a couple of thought leaders are having exactly those thoughts to direct their initiatives and strategy into the direction.
Yeah,
Interesting.
and you got to remember that the legacy operators and brownfield operators, they're dealing in the world of realities and margins. But similar to how Uber was super cheap when they first started, we might end up in a bubble, physical AI bubble, where manufacturing is subsidized to a point where, you know, making money is not really an issue for 4 or 5 years. And in that scenario, how can you run a profitable business if you're not being flooded by all this capital?
Mhm.
So the only approach there is to try to compete somehow using some kind of service from startups or other innovators and hope that you can survive. But like in a subsidized world, it becomes really difficult. All the math changes.
So, Miroslav, from your standpoint, especially since you deal with startups, so I think I've never seen startups interested in the industry so much so before industrial AI. I mean, I can pretty much, at least till I will say last month, I've always come across a new company every week, at least one new company every week. What do you think are the startups sensing here? Is it the AI hype in general, or do they really see something missing in the industrial world that they think they can really contribute and capitalize on?
It's very trendy. I mean, Momento's been doing this and just this for about 15 years now. The last 2 years have really changed. Started in San Francisco, but now even in Europe, you see it quite often. And usually it's coming from people who've never been in industry or operators in the first place. But somehow they're getting, pre-seed rounds with 45 million valuations or more. And so it's become a much more difficult job for us, not because there's less startups, but because there's many that will never return the investment. And Momenta, all of us were operators or enabling technologies in the past. All of our LPs are strategic corporates. Like in the newest fund, it's Rockwell and Nippon Steel Solutions. So we feel like we have a little bit of an edge to actually connect with these startups and know which ones are actually doing the hard work and which ones are just trying to scoop up really easy capital. And unfortunately, there's a lot of liquidity in this space right now.
Mhm.
I would
Boris?
have a couple of anecdotes here. I know of a startup and won't mention the name that was really putting high AI efforts into robotics and palletizing and depalletizing solutions and picking solutions, right? And they were IT and AI experts and developed their solution, and more or less they failed and they don't exist anymore as soon as a customer would require OT integration during deployment, right? So as long as a work cell could stay totally autonomous, I have a machine vision solution that looks at a conveyor belt, and if something is on the conveyor belt, I pick it up, right? Okay. If the customer would say, hey, I need MES connectivity, or I really need you guys to connect to this PLC because, that's what my process requires, it would take them months and months and months, as they didn't have an industrial background and OT background, to get, the understanding, the knowledge, the skills, the resources in place to do that, which ultimately broke their neck. So it's great to have many startups with an IT and an AI background, and then they hit the OT wall, and that not just happens once, it happens many times. My explanation for the steep increase in the number of startups is a different one. the more digital industry becomes, the more interesting are they as a market. So, when I have an IT background, an AI background, and have a clever idea and have, done some studies at university and feel skilled and equipped to do stuff, um, I really can start. The easier, the more digital the environment is. Now, I mean, OPC UA started, I don't know how many years ago, right? And, companies came together, defined the data standards, defined the semantics, worked jointly on OPC UA companion specs. But only now OPC UA companion specs are implemented in certain machines, and the newest generations of those machines delivers what I need to access in terms of data via OPC UA, right? Injection molding machines, Euromap standard, and all of that stuff. Now, that battleground is prepared, but only 2 or 3 years ago. So that's one factor. The second factor, and now, startups can really leverage that and build their solution on top of these assumptions and concepts. The second thing is a lot of stuff in industry is unstructured, geometry, product documentation, solution documentation, requirements, documents, codes and regulatory requirements. Engineers need to kind of crawl through that stuff. Prior to generative AI, we didn't have the tools to crawl through unstructured data and convert it into something that is digestible in a structured way. Natural language processing was so much in its infancy, or in other words, generative AI and the large language models have multiplied the power of natural languages, by factors of 100. Now we really have the tool at hand to convert unstructured data into structured data, and use it for the consecutive processes. So that adds another momentum to startup activity, and that's why in several areas we also see a lot of fantasy, if not greed, in the venture capital scene.
And it's interesting to know that the bulk of the interest in industrial AI is coming from across the pond in the Silicon Valley. Again, we are having a scene here now in Europe as well, but I think the bulk of the momentum is happening there in the US. And I think it's largely colored by the IT side, the IT, I would say, ecosystem. And when it tries to land in the OT ecosystem, as you mentioned about that startup that did not take off, I think we see those challenges. Now, let me go back a bit and try and understand this. Now, do you think for industrial AI to succeed, do we also need new players, new, I would say, value chain participants to come? For example, if there is a brownfield company that wants to adopt industrial AI, and Boris, as you mentioned, borrowing your lexicon there, so they are going to inject some fragility into their operations. And would an industrial insurance or a risk underwriter, I'm introducing this concept, be of value here? And do the companies that promote, for example, industrial AI solutions, especially companies like Siemens, for example, need to start thinking about such, I would say, clusters in the value chain?
Absolutely. And there's a good example. For now 5 or 6 years, the insurance company Munich Re is offering an insurance against underperformance of AI models in business contexts, right? And this insurance works for end customers who want to kind of be, safeguarded from effects of underperforming AI, but it also helps and can be leveraged by the startups themselves, as they would need to do all sorts of financial allocations, and I don't know the correct term, but if you build up a risk and you need to financially reflect the risk in your P&L, because you have to pay penalty or you have to pay damages in case AI underperforms in an industrial context, right? And as our factory automation ex-CEO, at least Rainer Brehm, used to say production doesn't have an undo button, right? So there are these types of offerings evolving, not on a large scale, but they exist. And by the fact that they exist, it backs you up. It backs your idea up, Karthik.
Yeah.
Yeah.
Miro?
Super relevant, right? Like risk has to be underwritten. Innovation, it has inherent risk.
Mhm.
Otherwise, you just stay stable. So, what you could imagine a large investor or P firm creating some kind of automation stack, uh, acquiring the long tail of manufacturing firms, diversifying that risk, right? Underwriting the risk, but diversifying across many factories, trying to implement all the automation at scale and standardizing across. And in that case, then they sort of act like the insurance company because if 10% of their portfolio fails to adopt the innovation, it's okay because the other parts actually now are much more productive. But it only happens at scale, right? And it's actually much bigger than Siemens or Rockwell or anyone's market cap. It actually is a much bigger market. And I think that's why you're also seeing all this liquidity is because I think there's this thesis that we're getting the largest market in the world of building stuff, right? That used to be slow and hard and grinding.
Mhm.
And there's this idea now that, well, what if we can now scale it and monetize it as if it was software or software-like? And I think that's whether that's right or wrong, who knows? But I think that's why now that computation is happening, where they're taking this huge market and then adding a multiple onto it that before was irrelevant in the legacy system.
Mhm. Interesting. Now, since we're talking about risk, let's go to the product itself or the value proposition of industrial AI itself. How much is reliability still a concern for the end customer when it comes to industrial AI? I mean, we see a lot of developments happening, for example, in the consumer space. So we are seeing the advent of, hyper agents now, like OpenClaw, and now we are seeing some new advancements coming in from players like Claude. But the real challenge is identifying a use case and then still relying on it. So this question is even more magnified in the industrial space. So as Boris, you mentioned about, Rhinobrain saying, production does not have an undo button. So you can't install an agent that goes haywire. So is reliability of industrial AI the biggest or the biggest elephant in the room that nobody talks about?
Miro, would you like to start?
Yeah, 100%, of course. Like either it's reliability or you increase the output or the efficiency so dramatically
Mhm.
that you're okay with being unreliable in your production because the unit economics have significantly or exponentially changed.
Yeah.
But if you
Mhm.
can't do that, then it has to be reliability, right?
Okay.
And this is a particular challenge in multi-agent environments. Yeah, we are all very excited about agentic AI. And this is also for the audience, I must urge you when we are talking about agentic AI in industry, you need to make semantically sure that you distinguish between AI and non-AI agents. Industry will only, agentic AI in industry will only work if we pair non-AI agents up with AI agents. AI agents may be great in generating stuff, yeah, 10,000 variants of a potential product design. But then I need to take these 10,000 variants and I need to run them through a series of simulation. And how does the simulation expose itself to the agentic layer? It basically exposes itself as a non-AI agent to the agentic layer. So the agentic layer can talk to the simulation and say, why don't you take the 10,000 variants and tell me which of those, tell me the 20 that work best. And only if we pair the probabilistic nature of AI with the deterministic nature of all the tools that we have, rule-based reasoning, rule bases, knowledge graphs, and traditional simulation and all of that, we can make sure that the output is tight. Now, will production lines run on agents? I doubt it. What is really amazing is how agentic AI can speed up processes that are today performed by humans and require a lot of human interaction. So, for example, if we have 5 personas that need to work together to design a production line for a customer, right? There needs to be someone who is intimately knowledgeable about the electrical side and energy side of a production line. We have someone who is really into automation and the PLC code. We have someone who is into HMI code. We have a couple of roles that are working on the required documentation, the machinery safety checks, and all of this, right? So you have these many experts that need to come together to build a production line. If you translate this into the agentic world, what will happen? You have an agent that is super great in electrical wiring. You have an agent that is super great in writing documentation, and so on and so forth. Now, the interaction time between these agents are seconds, while the interaction time between human experts, that takes ages. Why? Because everyone is so busy. So if I'm working on a project is finished, everyone needs to come together because the customer wants a change. The project is finished like 3 months ago, right? And the same experts need to sit together again to implement a change on the production line. It takes 2 to 3 weeks alone until I get the meeting between them, right? And this is where agents maybe just will produce an 80% solution. But the interaction between the expert roles in an agentic environment will be a matter of minutes. And this is amazing. And this is where agentic AI in the industry will unfold its potential much more than in the production line itself. If there's a lot of automation in the production line, why should I convert that into something that is more agentic than it is today? Sorry for being a bit lengthy on that.
Yeah.
But the value proposition of many different agents specialized working together is really taking the very lengthy processes of human interaction away, in a sense.
But how do we verify the output coming from these agents?
By simulation. And simulation means digital twins of components, digital twins of systems, and then maybe even digital twins of very complex systems like a plant. And this is why the idea of the industrial metaverse is so important, because what does it do? The industrial metaverse is basically a platform that allows you to simulate many, many different digital twins with each other. It's an aggregation platform for digital twins. Forget about the goggles, please. Forget about the 3D vision stuff. The immersive engineering is a marketing hype. The key attribute of the industrial metaverse is that it can aggregate many, many digital twins to simulate a system. And if we do this deterministically, more or less, then we can take, many different designs coming from many agents. This agent designed an electric drive here, produced a digital twin for it. This agent even, a couple of agents designed a machine and produced a digital twin for it, maybe exchanged in the asset administration shell, whatever. And then you simulate it holistically on a system level, and then you say it's working. Let's go into physical implementation, more or less. But that's, and today the digital twins, last comment, and I'm sorry to be kind of sidetracked to digital twins. The problem of the digital twins today is they are always bound to their authoring tools. I have an authoring tool, and I don't exclude Siemens from that, right? We have an authoring tool for a design of a machine, and then you create a digital twin, but the runtime environment for the digital twin execution is actually the authoring environment, right? And we need to decouple it, because only if we can decouple it and simulate it all together in the industrial metaverse, we can take components from different vendors. We can take machines from different machine tool builders, to build production lines and then simulate several production lines in a production system overall.
Mm-hmm. Mm-hmm.
Yeah.
I know
It-
I haven't smoked anything. It's
No, no,
we
no.
we we already see this in semiconductor, which is I think the most mature industry. But when you go to a manufacturer, the first thing they say is, "Why would I run an agent if things can blow up if they make the wrong decision?" And that's exactly the solution, right? Is you have them decisioning in the virtual world, and then that output after many many simulations becomes a deterministic output. It's not just one go at it, and in a way you're allowing the agent to prepare instead of trying to make a decision on the fly. I wanted to go back to the silos, right? Because this is really important for our gap, the missing middle, right? AI forces decisions in real time across department silos and even sometimes across factories. And because of the org charts and how we structured things, those guys never talked. So now you have all this AI that, for it to truly work, needs humans to change their entire org chart sometimes.
Yes.
And what do we end up with, right? We end up with saying a rejection of that transformation because it's painful. I want to own my department. I don't want to share. And then you end up with pilots that are incremental, very specific solution cases, and you never actually grow into infrastructure change across the factory because a lot of the work is done at the department level with little side projects. Uh, and startups try to do this because they're like, well, if I try to tackle the whole factory, it's going to take me 4 years. I'm going to go bankrupt. But if I just, you know, go and attach to this one department, maybe I'll get like $300,000, and then I could survive. So it's this self-fulfilling doom loop where uh, how legacy is structured is contributing, and then startups needing to survive is contributing. And it's actually then lengthening the process of real change.
Yeah, agreed.
No, I think that's a very good point. I think the current OT structures that we have in place are based on human competencies. Now,
Mhm.
when you look at an agent does not, for example, does not just need to do quality control or does not just need to do, say, metrology. It can do all of it together. So
Mm.
as you put, Miro, I think the challenge that we're currently having is we are targeting industrial AI's value proposition based on existing structures which are human defined. But AI in itself can go beyond the human limitations that we have. Like, for example, I'm an analyst in the industrial space. I cannot analyze the space of, say, automotive. But an agent can pretty much do what I do and what it needs to do in the automotive space. So I think we need a new greenfield organizational design that breaks the shackles of existing human structures, human defined departments, to really realize or to fully realize the value of industrial AI. I know again I'm also not smoked anything, Boris. I'm just trying to think about it, but it just keeps the level of abstraction keeps increasing. Let me ask you maybe another question. Again, I'm going to come to something very tangible. An interesting point made by one customer when we were doing some research on industrial AI adoption recently. I asked a question: what is the biggest challenge that you think you face when it comes to industrial AI adoption in your plant? He didn't talk about the technology or the issues or reliability. He said cloud adoption.
Yeah.
Again, missing link. This is an ecosystem gap. And again, it goes back to Boris, what you were mentioning. We are talking about something physical, which is not, the OT side is not moving ahead because it's not gone digital. And taking one step further, we are still not moving to the cloud. Do you agree with this?
Well, let me give you an example that is really coming from the ground, right? We have just launched a year ago um, a virtual PLC.
Mhm.
And it's selling quite nicely, and Audi is adopting it and so on. And then we had a couple of market analysts and customers who said, well, there are solutions out there where a PLC has already been containerized and virtualized 5 years ago, right? So what's the news? I mean, what do you got? First of all, why hasn't it been adopted? And then what's the difference with the VPLC that you guys are offering? And here's the difference. It's fairly easy to put PLC, it's a Linux thing, right? That runs specific code fast, right? To virtualize it. But what industry really requires is determinism on a resource allocation side, specifically in the network layer. I need to be absolutely sure that my CNC machine receives a message within 10 milliseconds, right? And the more precise the CNC machine is, the faster that communication must be. And I can only establish that communication if I can guarantee the latency between the PLC and that machine, the receiver of the message. And Intel had to rewrite network card drivers to enable us at all to establish a virtual PLC that has the determinism on the network layer. Again, it comes back to determinism. And it's easy to say, hey, aren't we all behind? Aren't we too slow because industry and the shop floor is still not adopting cloud concepts? No, I cannot wait 180 milliseconds for the message, right? 5G isn't there where it is supposed to be, unfortunately.
Yeah.
Because 5G would also have in a certain version a guarantee of message delivering times. And these are the hard facts. And then it's all good and great and elegant to have an IT architecture that uses virtualization, but the CNC machine must get its bloody message in 10 milliseconds.
Yeah. No.
Welcome to reality.
You're seeing this paradox of abstraction and virtualization, but then also more and more things going on the edge at the same time because of these gaps, right? That Boris is talking about.
Yes.
I think we have a few questions, and I have just received a notification that we need to wrap this up in 5 minutes. So I'll go to the questions. This has been very, very interesting. So number one, I think this is from William. For industrial side, those lower industrial side, will the back office transformation go faster at least?
I would say yes again, right? The more digital you are, the easier it is to adopt AI. And I have seen incredibly beautiful solutions. There's one example, Paylett, for example, doing production scheduling with genetic algorithms. And they put themselves on top of an existing MES and do a 15 to 20% increase in scheduling efficiency, right? And they don't need to connect to the machines. They connect to the MES and that's digital. So, back offices being digitalized, yes, I wouldn't say it's a low-hanging fruit, but it's definitely a lower-hanging fruit.
Yeah, agreed. I think the problem that I see, and maybe this is because I just got a scar from it 2 weeks ago, is the humans, right? Like, it doesn't matter if everyone in the factory says this is what we need in terms of innovation or automation. If the procurement guy says, well, I get my bonus based on what discount I get, and the startup can only offer a 30% discount and I need a 50% discount. And I'm going to shut down the whole thing because I don't get my little discount, so I don't get my bonus, right? So like, maybe this is a soapbox for me, but there's so much potential, there's so much opportunity. The people have to feel committed. They have to feel like, oh wow, this could actually change people's lives if we get this leap in technology implemented, and not just business as usual.
No, makes a lot of sense. I think William followed up with another question, and will that help catalyze the OT side? Essentially, back office leading to front office OT transformation. My understanding is, just for the paucity of time, I'm just going to answer this, William. William, I think this could help definitely. I don't think it will not help. So there is a third question coming from Durga Prasad. So he is asking, with lines blurring between physical AI to digital twin, what are the key elements that can bring lifecycle automation economies in physical AI? Physical AI, okay, it's a pretty long question. Okay, I think the question is he's asking, what elements do we need to bring economies of scale when it comes to physical AI in the OT world? I'm sorry,
It's a complex question, but what I wanted to I would again refer to the ability to simulate virtually on all different levels before I finally deploy, right? And this isn't an established discipline. This is a very young discipline.
Okay.
Simulation of production is common in semiconductor and is common in automotive, and then it's not common in many other segments of industry. And we, this is absolutely needed, because only then we can take out the probabilistic aspects that will continue to exist also in physical AI, make sure it works, to a high degree of certainty, and then deploy it down, maybe paired up with virtual commissioning and virtual PLC concepts, for example.
Miro?
Yeah, just one addition here. We have to talk about the digital twin being dynamic and conforming to the realities of the world and not real time, but quickly, because this is, I think, where Boris was talking about, where if the automation cell is contained, then it's great for physical AI, but you need a digital twin that's adapting to the real world in order for the simulation to even make sense. Otherwise, you're just creating training decisions that actually break in the real world. And that's where I think physical AI sometimes struggles, is they use digital twins that are not realistic.
Very good. I think there's the last one from Durga Prasad again. Please share some insights on orchestrator play in the industrial AI world that can digitize end-to-end process or a sub-process in an assembly line, or spare parts availability on a critical production line.
Well, first of all, spare part availability is a predictive maintenance case, and then predictive maintenance is a difficult use case because it is commercially almost irrelevant. It has been the truth is, it has been incredibly popular for the last 5 years.
I've used it for 15 years, Boris, in my presentations.
For 15 years even. Why? Because if you do predictive maintenance, you don't really interfere with the primary core process, so you don't damage anything. And that's why production line managers are saying, do predictive maintenance. Maybe it's helpful, maybe not. But at least you don't kill anything, right?
And how do you attribute it to what you did? Right?
Exactly.
Like,
yes.
Who actually predicted the maintenance?
Let me tell you something about the orchestrator. Industrial reality is so incredibly diverse and has reached so high levels of excellence that I don't believe in a generic capability of orchestrating, right? At least not now. Maybe that changes in 15 years from now. What I really do believe is very strong ML ops capability. So AI needs to be operated 24/7. Models must be monitored. You must react and respond to data drift, to changes in the environment that happen all the time. So ML ops capabilities are a foundation for AI initiatives, and you need to establish this. Typically, you cannot establish this on a factory level, but need to do it on a cross-factory level. So it scales a bit, because it's 24/7, by the way, right? So that's expensive in itself.
Okay.
If that makes sense.
Yeah, thank you, Boris. Miro, I have 20 seconds for you to give your thoughts on this.
No,
Sorry.
pretty much agree with Boris. So I think we're good. I'll give you time to say something else for us.
Definitely. So thank you so much.